4.2 linear programming simplex method. We're going to be doing maximization problems today. And here are kind of the directions for how to do the simplex method. And it looks kind of complicated, and I suppose it is. There's a lot going on. However, we pretty much already know how to do the first 4 steps. Okay, the first 4 steps, that's basically setting up the problem. Steps 1, 2, and 3, we knew how to do from the last chapter. We're trying to write the problem basically. Okay, well, I guess last section we started talking about slack variables, but anyway, steps 1 through 4 are the setup. Steps 5 through 8, that's more where we're talking about simplex. And it seems like there's a lot going on there, but these 4 steps, these are the important ones. Okay, so let's go through this, and I'll try to break this down. Okay. So step 5 says locate the most negative indicator. Most negative. All right. So, if you're looking at a couple of numbers and you see -2, -5, and -3, and +4. Okay. Which one of those numbers is the most negative of those numbers? -5 is the one I'm talking about. Okay, so I know that most negative is kind of a weird, quirky kind of phrase, but when I say most negative, that's kind of what I'm talking about. The one that's farthest away from 0 and it's negative. Okay, so we're looking for that. It says if there's 2 of them, or if there's a tie, pick the one on the left. 6 says form the necessary quotients. I'll show you that later. Disregard quotients with 0 or a negative in the denominator. The smallest non-negative quotient, so that's going to be important. The smallest non-negative quotient is kind of what we're looking for. Gives the location of the pivot. So you're gonna have to find the pivot element. That's the last 2 questions in your first homework assignment there. But find the pivot element, and that's what we need to do. Again, if there's a tie, it says pick the one nearest the top. Step 7, use row operations. So that's where you're going to be doing row 1 minus 2, row 2, that kind of stuff to find zeros. And then step 8, if all of the indicators are positive or 0, this is the final tableau, the final answer. If not, so basically if you see any negatives on the bottom row, you're going to go back and do this again. So it's a loop. You do 5, 6, 7, 8, and if you see negatives, you have to loop back and do it again and again and again until you don't see any more negatives down there on the bottom. At the end, step 9, there's your solution, okay? Specifically, your optimal solution. So there's the setup, there's the simplex loop, and then there's the solution. So let's look at example 1. Example 1 looks an awful lot like something that we've done. In fact, I graphed it from last chapter. I'm going to show you simplex, but I wanted to remind you of what happens when we graph. Okay, if you can graph this thing and look at the corners and do the method of corners, you can just plug in those corners. So check it out. If I did 0, 0, that would be 25 times 0 plus 30 times 0 equals 0. And 25 times 65 plus 30 times 0. I believe that's 1625. And 25 times 25 plus 30 times 40 was 1825. Bless you. And up here at the top, we had 25 times 0 plus 30 times 60 equaled 1800. So we had 4 corners for that feasible region. And the method of corners found us a maximum value of 1825 at this point. Okay, that was the solution. That's what we did in chapter 3. Chapter 4, though, is going to get us to where we can do more than 2 dimensions. Okay, we'd have a hard time graphing a 3-dimensional or 4-dimensional shape. So we're just going to see what happens when we go into bigger dimensions. So if you think about the steps that I just showed you above, steps 1 through 4 were the setup. We've already got the problem set up, but we want to install slack variables. So your main inequalities here, you're going to put slack variables in. And I don't really care about these two inequalities, but the two main constraints there, put in S1 and S2. So we want that simplex tableau. I highly recommend you list out the variables at least once and try to line everything up under those variables. We have x1, x2, s1, s2, and z. Those are our 5 variables in this problem. So look at the constraints. The constraints, the top one says 1x1, 1x2. We put in an s1. Zero S2, 0Z, and it equaled 65. The second constraint said 4x1, 5x2, 0 S1, 1 S2, 0Z, and it equaled 300. Underline. And then remember, for the bottom line, you have to have standard form. A very common mistake that people make is they'll just put down a 25 and a 30 right there, but that's messed up. And I told you why that's messed up. You're looking for negative numbers. Negative numbers mean that you're not to the optimal solution yet. So if you just wrote down 25 and 30, you'd be done, okay? And you wouldn't have to do any work. That should strike you as odd, okay? Remember, the vertical bar is the equal sign, and so we need all of our variables to the left of the equal sign. I'm going to subtract that 25x1 over, and I'm going to subtract that 30x2 over. Okay. I have no slack. I don't have a slack 1. I don't have an S2. I do have a Z. Cut! So a common mistake that people make is they forget about this Z. Make sure you put the Z in there. So the 1 is under the Z column. And then I cleared everything out on the right, so there's going to be an equal 0 there. Now, if you think about it, we've got a solution to this table, this tableau, and x1 equals 0 and x2 equals 0, because those are non-basic variables, right? And the z value is 0, but that corresponds exactly to this corner on my feasible region. Okay, so I'm doing the exact same problem. I'm just doing it without graphing it. Okay, so hopefully I have enough room here. The process says, okay, do you remember what the process said? Step 4 says locate the most negative indicator. Well, indicator just means under the bar, the bottom row. So most negative is negative 30, correct? So what I want you to do is circle that column. Oops, circle that column. And actually, you know what? I want you to write that down in these steps, okay? Most negative, circle the column. And then step 6 says smallest non-negative quotient. I want you to circle the row. That's how we're going to find the pivot element. Circle the column, circle the row. So where are we at here? Okay. So the most negative is negative 30. Negative 30 is more negative than negative 25. That's negative 30. Now, it talks about quotients in that next step. form the necessary quotients. Well, we see the numbers that we've circled. This number 1 forces me to look at this 65. And so what I'm talking about is we're going to go 65 over 1 is 65. And then this 5 makes me look at the 300. I'm going to form a quotient 300 over 5 equals 60. Okay? So remember what it said. It said the smallest non-negative quotient. So whichever one's smaller. Smaller non-negative is 60. Okay? Smallest non-negative is that 60 right there. So that's the one I want. Circle that row. I've just circled a pivot column and a pivot row. There's one number in particular that I've circled twice. The number that I've circled twice is the pivot element. So that question on your homework that says find the pivot element, that's the pivot element. You circle the column, you circle the row, whatever you've circled twice, that's your pivot element, okay? So what do I do with that information? I use that 5 to zero out this 1 and this negative 30. Just like we did back in Gauss-Jordan, okay? Just like we did back then. We're going to use like row 2 minus row 3, that kind of thing, okay? But we have to use the 5 to zero out the other 2 numbers in that circled column, okay? So let's do that, okay? The first one I'm going to do is this 1 right here. And so I think I should be able to do 5 row 1 minus row 2. 5 row 1 minus row 2. That's going to cancel out my 1. So let me look at 5 row 1s minus row 2. That'd be 5 minus 4 is 1. Try really hard to keep your variables lined up, okay? So you can keep track of which one's which. That's in my X1 column. And then 5 of these minus this is going to be 0. 5 of the row 1s minus the row 2 is going to be 5. 5 of these minus this is negative 1. 5 of these minus this is 0. Vertical bar. 5 of the 65s minus 300. Okay. Where'd it go? 5 65s minus 300 is 25. Okay. The circled row can stay the same, so just leave it alone. 4 and 5, 0, 1, 0, 300. Underline. And then we've got to get rid of the negative 30 using the 5. So least common multiple is 30. You need 30 minus 30 or negative 30 plus 30, something that's going to make 0. To me, I would probably do row 3 plus 6 row 2s. Row 3 plus 6 of those, that's 24. Negative 25 plus 24 is negative 1. At this point right now, I'm a little disappointed. Do you know why? I'm going to have to do this again. As soon as I see a negative on the bottom, I know I'm not at the optimal solution. I'm going to have to do it again, okay? But I still have to finish this one. I can't skip it. So row 3 plus 6 row 2s, well, that's 0. That was my whole point. And this plus 6 of those is 0. And this plus 6 of those is 6. This plus 6 of those is 1. And this plus 6 of those is 1,800. Okay. So we can read a solution out of this. Your X1 value is what? Can you see it? X1 is non-basic. So X1 is 0. X2 is basic. What's X2? 300 divided by 5 is 60. And then Z would equal 1800, right? Z is basic. Okay? So, if you look back at the graph, what we've just found was this corner right here. 0, 60 produced a value of 1800, but that wasn't the maximum. And you can tell it's not the maximum from your Simplex Tableau because I still see a negative on the bottom there. So negative on the bottom there, we're going to need to, I'm going to erase this just to get more room. We're going to need to do this step again, or do this whole thing again, okay? So go back, remember these steps are a loop. We loop back to step 5, and it says most negative. Step 5 says most negative, and there's only one negative. It's a -1. So we know we're going to use this column. And then we use those columns and find the quotients for all the far right. Okay, so 25 over the 1 is 25. And 300 over 4 is 75. So 25 is the what do they say? The smallest non-negative right there. Okay, so circle that row. The number that you have circled twice is your pivot element. Pivot row, you can just leave it alone. 1, 0, 5, -1, 0, bar 25. But then that second row, I'm going to get rid of the 4 using the 1. Get rid of the 4 using the 1. So that would be what? Row 2 minus 4 row 1s. Should be starting to get the hang of that. And that's going to be row 2 minus 4 of those is 0. And this minus 4 of those is 5. And this minus 4 of those is -20. And this minus 4 of those, that'd be +4. 1 plus 4 is 5. 0 minus 4 zeros is 0. 300 minus 4 of the 25s, that's 300 minus 100, is 200. Underlined. Bottom row, -1. I got to get rid of a -1 using a 1. Well, that's easy. We just add row 3 plus row 1. Add them. Let's do green. -1 plus 1 is 0. 0 plus 0 is 0. 0 plus 5 is 5. 6 plus -1 is 5. 1 plus 0 is 1. 1800 plus 25 is 1825. Well, that number looks familiar. Okay, but notice your bottom row doesn't contain any negatives. I don't care about negatives in general. These negatives are fine. I'm looking at the bottom row. The indicators are all non-negative, so I know I've reached the optimal solution. Specifically, look at your variables. I see basic variables here and here and here. I see non-basic variables here and here. So what are those values? Well, x1 is 25. Remember how to find that, okay? You look at this number and it forces you to look at this number, okay? For x2, you have to look at this number, which forces you to look at this number. And so for x2, 200 divided by 5 is 40, okay? Your slack variables are both non-basic. They're going to be 0. And then your z value, okay, you're looking at this number, which makes you look at this number, 1825. Okay, if that looks familiar to you, it should, because that's exactly what the answer was when we looked right here. This point was 2540, and the max profit was 1825. That's what we've got. It's the same exact problem. You're getting the same exact answer. It's just without graphing. Okay, was graphing easier? Well, sure. But that's because the problem only had 2 variables and the problem was easier. Okay, but simplex method is going to be more versatile because we can expand it to 3, 4, and more dimensions. Whew.